So everything that we've done up until now has been pretty basic and easy to deal with, but we're going to ramp it up a notch. I have f of x equals 6 times the cubed root of x. And I'm going to go ahead and take the time now to write that as 6x to the first power. So it's x to the first. But I'm taking a cubed root. Okay? So the first thing I know is that this is not a polynomial. And I am also concerned because I've got a radical. But remember, I'm okay with any number under an odd root. Okay? In other words, I can take the cubed root of -8. I can take the cubed root of -10. I can take all of that is okay. I can also take the cubed root of +8. I don't need to worry about my domain being affected. Okay? So that is point number 1. I do not need to worry about my domain being affected. So what I want to do is find concavity, concave up and concave down. So first derivative means I'm going to drop my 1/3 out front. So 6 times 1/3 is going to be 2. X to the -2/3. Okay, so 2 times x to the -2/3. If I were to go ahead and rewrite this and set it equal to 0, I could determine increasing, decreasing, critical numbers, all that kind of good stuff. But I'm not worried about that. I'm worried about concavity. So I'm going to take a second derivative. And when I drop my -2/3 out front, I get a -4/3 x to the -5/3. And boy howdy, what does all this stuff mean? So let's rewrite for just a second. Remember, a negative exponent actually means I need to drop that x to the denominator. So I've got a -4 over 3. And then my denominator, this is actually x to the 5th power, but I'm taking a cubed root. Okay, so that's what all that stuff means. Now, you should notice something. You have a variable in your denominator. If that variable, x, turns into a 0, then this entire denominator goes to 0 and your function is undefined. Okay, I still don't care that I've got a root going on. I do care that if I use 0, my function will be undefined. The next thing I notice is that the only way to make a fraction equal to 0 is if my numerator equals 0. And that is impossible to do with this one because I can't just say, poof, you're a -4 and I'm going to turn you into a 0. Okay, so it is impossible for my function. What do you have? This dog is eating my pen. Stupid. Oh, holy cow. Look at my hand. Anyway, gross. Okay, I am so sorry. Here we go. So the only way to make a fraction equal 0 is for its numerator to equal 0. I cannot just say, poof, -4, you are now a 0. I don't have a variable to interact with. So the only thing that's causing issue is 0. That is the only thing that is causing an issue. Okay, be very careful because you're starting out negative. So this is a number that I'm interested in. I'm allowed to use it up here because if I evaluate at 0, I would get a 0. So the point 0, 0 is on that graph. But remember down here, you're taking derivatives. So the issue there is going to be, can I make my function equal 0? No, but I also know that 0 is off limits. Okay, it'll make my function undefined, which means I'm interested in 0. Something's happening there. Okay, so grab a point on either side. So I'm going to grab, I'm just going to grab a -1. So a -1 to the 5th is -1. Okay, the cubed root of a negative is negative. So right now I have a -4 over a +3 times a negative value, which means I got a negative over a negative, so this whole thing turns positive. Okay, so he is concave up. Well, grab me something over here. So let's grab +1. So my numerator is -4, so he's negative all day long. My 3 is positive. Okay, and then if I take 1 to the 5th power and take its cubed root, it's 1. Okay, so that turns into a positive. So a negative divided by a positive is negative. Okay, so he is concave up from negative infinity to 0, and he is concave down from 0 to positive infinity. Okay, so that one was just a little bit exciting. So let's do one more exciting one, which I'm actually going to flip my paper for. Here I go. Okay, so I have g of x equals the square root of x minus 7. So immediately, this is not a polynomial. It's not going to be as straightforward. I can rewrite that as x minus 7 to the 1/2 power. Now, this is an even root. I cannot have negatives under an even root because it's impossible. Okay, what are you going to take the square root of that will give you a negative answer? So it's not going to work. So what I need to do is restrict my domain. So I'm going to say everything that is under this radical needs to stay positive or equal to 0. It needs to stay positive so that I can take its square root, or it needs to be 0, which means the square root of 0 is 0. Okay, so I'm going to solve that. So I'm going to add 7 to both sides. So x is still an infinite number of things. It just has to be bigger than or equal to 7. So right now, when I get down to here, I know that from 7 and to the left is gone. It is impossible. It doesn't exist in this world. Okay, so I'm only interested in 7 over. Now, first derivative, which will tell me increasing, decreasing, constant, and critical numbers. Drop your exponent out front. Drop your exponent by 1 times the derivative of the inside, which is 1. So we don't care. All right, so I could set this thing equal to 0 and solve it, all that kind of good stuff, but I'm not going to. We're going to go to a second derivative, so I'm going to drop my negative 1/2, and I'll get a negative 1/4, x minus 7 to the negative 3/2. And now I need to rewrite. So I've got a negative fraction, and then this is going to be a fraction. So I've got a negative 1/4, and then that negative says to drop my x minus 7 to the denominator. I know it's x minus 7 to the 3rd. I also know I am taking a square root. Okay, so now we're in the same position as we were before. Can I make this equal 0? No, I cannot. I also know that 7 is off limits. If I use 7, 7 minus 7 is 0, 0 times 4 is 0, and the whole thing just went to pot. 7 is off limits. So not only can I not use anything over here, but I'm also not able to use 7, which is fine because that's where it determines my interval anyway. Okay, that's where my interval is determined anyway. So grab me a number over here. So let's go 100. Okay, 100 minus 7 is going to be positive. A positive cubed is positive. The square root of a positive is positive. And a positive times 4 is positive. So when I shove in a positive number bigger than 7, my numerator will be negative. My denominator will be positive, which means this thing is concave down. And so on the interval, he is concave down from 7 to positive infinity. He is concave down his entire life. Okay? Concave down his entire life. Now, we are going to find inflection points. So those were the two scary ones. Now we're going to find inflection points. So I've got g of x equals 7x to the 3rd minus 3x. And please also remember that, holy cow, I forgot. I have no idea. All right, so we're going to do inflection points. So first derivative, I don't even know what I was going to say. All right, drop this out front. So I got a 21x squared minus 3. Okay. I don't care about that. I just care about inflection point. Oh, that's what I was going to say. Anytime that you need a y coordinate, always go back to your original function. Okay. Anytime you need a y coordinate, go back to your original function. Okay. So second derivative will tell me points of inflection. So drop your 2 out front. I got a 42x. Set that equal to 0, so x must be 0. Okay, and then I want to make sure it's an inflection point. I want to make sure it's a change in concavity. So if I shove in negatives, this will be negative. If I shove in positives, this will be positive. So it is a point of inflection. You just found out that it changes concavity at 0. So if I evaluate my function at 0, because I need to know the point, I need to know the y-coordinate. All right, so anytime you need a y-coordinate, go back to your original equation. So I'm going to evaluate at 0 because I did confirm that my x-coordinate of 0 is a point of inflection because it changed concavity when I did test points. It went from concave down to concave up. Now what I want to do is find my y-coordinate. So if I evaluate my original function at 0, 7 times 0 minus 3 times 0 is 0. So on the original graph, you have a point of inflection at 0, 0. Okay, so the last one that we're going to do in this section, we're just going to go all the way from start to finish. Okay, so I have g of x equals, and I've got 8x to the third minus 9x. And I want to find first and second derivatives and points of inflection. So my first derivative is, drop that out front. So I get a 24x squared minus 9. My second derivative is going to be a 48x. Set that equal to 0. Why do I feel like that was the exact same problem? No, it was 42. Sorry. All right. So you know your first derivative, you know your second derivative. Set that equal to 0, and you find an x value of 0. Confirm that it is a point of inflection. So if you shove in negatives, this will go negative. If you shove in positives, this will go positive. So it does change concavity. So now what do I want to do? I want to find the actual coordinates of the point of inflection. So I'm going to evaluate my original function at 0 because I need a y-coordinate. Anytime you need a y-coordinate, go back to the original equation. So 8 times 0 minus 9 times 0 is 0. So that is that is 4.2. 4.2.